Hey guys, welcome to the channel. So today we are going to be working on a trainer on how to train this simple ANN model. But first of all, before we get into that, one of you guys commented that I needed to explain this model as I just went over the code while I was writing it. And I do apologize for that. That was my mistake. Please skip to this timestamp on the screen if you don't want to see the explanation. Alright, now as for the explanation, we are importing the deep learning module torch right here, and after that we are defining an artificial neural network class right here, which is defined by class ann.module. After that we are defining a constructor which takes in input dim, hidden dim, and output dim. So you may be wondering what these are. So input dim basically is how many neurons will accept the input, and the hidden dims is how many neurons will accept the input from the previous layer of the neurons. So this can be as many as we want it to. We can heck even do it something like this. So let's say we have that part, and then we can do this also. We do that, and then we can do see self dot input, self dot hidden, then self dot hidden to hidden, and then self dot hidden to self dot out.
The greatest vtuber that's ever lived.
One of the conditions for this is that this dimension should match this dimension, because if it does not match, then the matrix multiplication will not be possible, which will cause the whole model to collapse. So as for this part, we are defining a sequential model. So what this basically does is when we pass in an input right here, it gets sent off to this part, which then automatically processes the inputs in a linear order, in a sequential order, I mean. So the input gets sent off to first of all the first layer, after which it goes to the ReLU process, and after which it goes to the output layer. And then we get our final output from that, and that's how the ANN model works. Okay, so now moving on to the training part, but before we get started, please do make sure to add this line to the model because I forgot to add it in the previous video. This is very important because we need to initialize the nn.module part of this code, and we also need to import torch. So now moving on to the main part of the training code, first of all, we need to initialize the model. So we are going to do model should equal to ANN, and inside of that we're going to do 2 comma 2 comma 1, as in for 2 input dim, 2 hidden dims, and then 1 output dim. After that we need to define the optimizer. So optimizer is going to be optim is equal to torch dot optim dot adam. We're going to be using the adam optimizer, and inside of that we need to write model dot parameters, and we need to write learning rate is equal to 0.001. That's going to be our base learning rate for this ANN model. So basically learning rate is how fast your model can learn from the training data. So that's a pretty standard value that we are using as for now. And after that we need to define the criterion. So it's going to be criterion is equal to torch.nn.mse loss, mean square error loss, because we are doing mathematical calculations. That's why I'm going to be using MSE loss for this one. So now that all of those have been done, we need to define how many loops are we going to train it for. So number of loops, we call that epochs in training a model. So epochs is equal to 2000. We are going to be training the model for 2000 loops, and now we need to set the model to the training mode. So we are going to do model dot train. Bam, there we go. Now we need to get started with the loop. So we're going to do for I in range epochs. After that we are going to do optim dot zero gradient. So what this is going to is it is essentially going to reset the gradients before each loop begins. I'm sorry for stuttering. And after that we need to do output is equal to model and x. And oh wait, before we get into that we need to define the data set. So we are going to do x is equal to, first of all we are going to define it in a list. So 1 comma 1. Yep, you guys are watching time lapse right now. Do make sure to subscribe in the meantime though. So if you guys did not realize this is the data set for XOR gate. Now we need to convert this data into tensor. So we are going to do x is equal to torch dot tensor and x, and we are going to do y should equal to torch dot tensor y. That's basically it. We have converted our raw numerical data into dataset. Along with that we need to do data type. So the type should equal to torch dot float 32. We are going to using 32 float for this one. And let me just copy this and paste it down here. So both values are now in floating point. Okay. Now we're going to do loss is equal to criterion, and we need to pass in um, out comma y or y comma out, whatever we want to do. Then we do loss dot backward, and we need to do optimizer dot step. After that, we need to print out the values if we want to. So we are going to do print, and the training loss is going to be loss dot item. Yep, in theory this code should work. Now let's try to run it. And see, here we are training our model. And we have trained our model. There we go. And we can also do this. So if you guys want to see if the model is working properly or not, uh, we can do this. So I've just pasted my small testing code that I had written somewhere else in this demo file up here. So, yep, we are going to set the model to evaluation mode. So it basically tells PyTorch that, okay, we are done with the training part of the model. Now we need to run it. So basically, if you want to run the model, you will need to do this every single time. Okay, then we are doing torch dot with torch dot no gradient. So it means we are disabling the gradient calculation, which is used only in inference. You guys can see this part. You can read it. I'm gonna be moving on. So we are calculating the output. So output is equal to model torch dot tensor 1 comma 1, and our ideal output should be 0 for this one and 1 for this one. So now if I run this code, we are going to see that the model is going to get trained, and then we should see both of those outputs. Yep. Okay, this was not in the script.
The greatest vtuber that's ever lived.